Okay, so today I'm going to do a video tutorial on how to solve one of the problems that you have in your homework set. All right, and I'm going to lay everything out just like you should be doing on the problems that you work out. All right, the problem that we're facing is this one here, a car traveling with an initial velocity of 21.6 meters per second, accelerates at a constant rate of 1.1 meters per second squared for a time of 2.8 seconds. What is the car's velocity at the end of that time? Okay, now I want to point out one thing. Your problem has different values in here for the acceleration and the time, but once I show you how to do this, you can just plug your own numbers in and you'll get the result. All right? So how do I go about doing this? Well, one of the things I do is I write down from the problem the things that I know. What do I know from the problem? Okay, I know the initial velocity is 21.6 meters per second. So I'm going to write down V0 is 21.6 meters per second. Another thing I know is I know the acceleration, 1.1 meters per second squared, and I know the time. In this case, it's 2.8 seconds. And it asked me, what is the velocity at the end of this? So what I need to find is this thing. Okay? So now let's take a look at the equations in our toolbox over here. All right? And I look at, this is from this week's toolbox, the added equations, and I look at these equations and I compare those equations to the things that I know. Well, the first part of the question doesn't ask anything about position, so I'm going to ignore that one. This equation gives me the average velocity. I don't need to know that. This equation here, that looks promising. It has a V0, which I have. It gives me an acceleration, which I have, and a time, which I have. And what I want to find is this. So this apparently is the equation I want to use. So I'm going to write that equation down over here, V0 plus AT, and now I'm just going to feed these values in here. All right? So V0, 21.6 meters per second, plus A, which is 1.1 meters per second squared, times the time, which is 2.8 seconds. I plug that into my calculator, and what do I get? I get a value of 24.7 meters per second for this. Okay? So we've got the answer now to part A of the problem. Now I want to do part B of the problem. Okay? Part B of the problem says, what distance does the car cover during this process? Okay? So now we are asking about distances. Let's put in the other things that we don't know. Look, let's substitute one thing we do know. We do know that V at the end of the process is this. I don't know if that's going to be important yet or not. All right? What we don't know is X. Okay? Now here's another little thing. One of the things that you can assume when you do this type of problem, unless it says otherwise, you can always assume that the starting position is 0. Okay? So let's take a look at this set of things that I have and look at the equations over here in our toolbox. And what I see is I see an equation that looks like this. Well, that looks promising, except this equation is for constant velocity, and we said we had an acceleration. So that one doesn't work. So I'm going to go down here and I identify this equation. Okay? I've got this, and this. All right, so let's come over here and write the equation down for part B. X equal x0 plus v0t plus 1/2 at squared. And now let's just start substituting in our values. x0 is 0 plus v0, 21.6 meters per second times 2.8 seconds plus 1/2 times my acceleration, 1.1 meter per second squared times my time squared, 2.8 seconds squared. Okay, I plug that all into my calculator and I turn the crank on that and I get 64.8 meters per second. Okay? I encourage you to go about solving your problems in much the same way until you get really good at it. All right? By reading the problem, listing out the things that you know, and taking your physics toolbox that I've given you, not necessarily writing it out, you can print it out like I've done, all right? And going through and comparing what you have with what you have for equations and what you need, and then making the appropriate substitutions. All right, I'll give you another one of these for next week.